All right. Well, welcome everyone. My name is Laura with the Plano Public Library, and I want to thank you all for joining us for today's program. Please note your microphone and video have been turned off. If you have any questions, you can type them into the chat. Heather will be monitoring the chat to assist you with any issues and bring questions to my attention. We will also be sure to leave time for questions at the end. A few housekeeping reminders that I'd like to share with everyone. Please note that this program is being recorded and will be made available on the Plano Public Library YouTube page for later viewing. Soliciting business or selling merchandise during library virtual programs is prohibited. Please show respect for our presenter and one another throughout the program. Zoom provides live captioning. The option is available in the Zoom toolbar. Welcome to Be a Citizen Scientist. This is a series of 3 programs, each focusing on a different citizen science opportunity. This week, we are going to talk about space-focused citizen science opportunities. But before we get started, let's take a minute to look at what citizen science is. Citizen science is a collaboration between scientists and people who are curious or concerned about the world around them and are motivated to make a difference. It was not until recently that science became an occupation. In the past, science was something done in your leisure time. For example, in 1674, Antony van Leeuwenhoek discovered microorganisms. He was a cloth merchant who made lenses to look at the weaves of fabric. And in his free time, he used these lenses, which were more powerful than microscopes of the day, to look at pond water. Today, he is known as the father of microbiology. Over time, science moved into the realm of professionals. Citizen science is a continuation of this tradition of the everyday scientist. Anyone can participate. The data collected by citizen scientists help professional scientists come to very real conclusions. Citizen science results in rigorous, reliable, and trusted science. Don't worry about having the expertise that scientists have. People who are not citizen scientists still have skills that are valuable to citizen science. As you work on citizen science projects, your expertise on the topic will grow. You are the expert of your surroundings. You know when something is different or off, and this is valuable when you are doing a citizen science project about the world around you. Citizen science projects do rely on experts to validate observations, and multiple citizen scientists review the same thing so that a trustworthy consensus is reached. Don't let a fear of being wrong hold you back. So, citizens in space. As of November 2023, 676 people have gone into space. 12 people have walked on the moon. These are the Apollo 11 astronauts on the screen here. But humans have been fascinated with space for thousands of years. The first documented record of an astronomical observation dates from 1000 BCE in Mesopotamia. You can see on the screen there on the left is an astronomical diary from Babylon that has records from 137 to 136 BCE. The observations include a detailed account of a total solar eclipse on April 15, 136 BCE. Even though so few people have visited space, there are plenty of opportunities for everyday people to explore the universe from the comfort of their own home. No liftoff required. Today, we are going to explore some of these citizen science projects. All you will need for these projects are a computer or a smartphone. And while there is a project you can participate in using your own telescope and submitting your images of objects in space, today we are only going to focus on those projects that do not require special equipment. Many of the NASA-led and other citizen science opportunities we will be discussing today are accessible through Zooniverse. Before we jump into them, I want to give a brief introduction to Zooniverse. Zooniverse is the world's largest platform of people-powered research. It connects researchers and their data with volunteers. Zooniverse's goal is to enable research that would not be possible or practical without volunteers. Now, accounts are not required to use Zooniverse, but you will want one if you want to keep track of the projects you have worked on. Sometimes these projects run out of data. This can end a project permanently or cause it to go on hiatus until more data is uploaded. Progress on the project is visible on the main page. If you find you really enjoy a particular project and it runs out of data, keep checking back. They might add more and it will become active again. So our first project we're going to look at is called Name That Neutrino. And the Ice Cube Neutrino Observatory is the largest particle detector in the world. You can see it there on the screen. It is located at the South Pole and uses thousands of light sensors that have been buried into the ice to detect neutrino particles and works to identify their astronomical origins. The observatory generates a terabyte of raw data a day. And while a machine learning algorithm that can identify the different types of signals they receive exist, it sometimes gets the signals misidentified. So by having citizen science looking at the signals from the Ice Cube Neutrino Observatory, researchers can compare their results with the algorithms so they can retrain those algorithms to more successfully identify different signals. And links to each project discussed today are being added to the chat as we talk about them. How to participate. So if this is a project that interests you, you will watch a video that shows a signal, and the screenshot on the left of the screen is a still of what that video can look like. And this signal is going to look like bubbles, and you will be classifying the movement of these bubbles as either cascades, skimming, or tracking. And you can see right next to the video, you would just click on what type of movement you see. And then if you end up classifying something as tracking, you will then be asked to further classify it as either starting tracks, stopping tracks, or going through tracks. And there is a field guide that is available that allows you to reference videos of different classifications. And you can always refer back to this tutorial for guidance if you are unsure. Our next one is Redshift Wrangler. Now, the light that reaches Earth from distant galaxies takes some time to get here. What we see now is not what is happening in real time. So, for example, the closest star to Earth besides the sun is Sirius, and the light in the sky that you see is over 8 years old. So because it takes so long for the light from other galaxies to reach us, we get a glimpse of what they looked like in the past and how they developed into the types of galaxies that we see today. This can give us insight into how our own galaxy formed. And this project uses data from the Keck Observatory and the Hubble Space Telescope. And so the image on the left, that's just the icon that they have chosen to represent their project. And then that is a timeline of light traveling through the universe. So in this project, you'll be looking at the redshift of a galaxy to figure out how big the universe was at the time that that particular light left the galaxy. You'll be picking out emission lines, peaks, and absorption lines, valleys in the spectra. And that spectra is kind of looks like a heart rate monitor. That's what you're going to be looking at. Now for each spectra, you will choose if the emissions and or absorption lines are spotted, if you can't find them anywhere, or I think there's something wrong with this spectrum. And then if you end up selecting emission and or absorption lines spotted, you'll be prompted to draw a box around them. And like our other project, there is a field guide with examples of what you're looking for so you can refer back to it if you need to. And anytime I do a Zooniverse type project, I find that the first couple of times I'm doing it, I rely heavily on that field guide to help guide me. And then the more I do it, the easier it gets for me to do it without that aid. All right, so now let's move on to Mars, and we're going to talk about cloud spotting on Mars. So clouds can tell us a lot about the weather and climate of a planet. On Mars, clouds form in the mesosphere part of the atmosphere, and they're called mesospheric clouds. These clouds are of interest to NASA for a couple of reasons. One of those is that Mars is a dry planet, but there is water vapor in the atmosphere that forms water ice clouds. But Mars's atmosphere is 96% carbon dioxide, which means carbon dioxide ice clouds also form. This ice is going to be similar to the dry ice you can purchase here on Earth. So what NASA wants to know is what causes the atmosphere to get cold enough for carbon dioxide to freeze? How do clouds change from day to night, during different seasons, or from year to year? And what are each of these clouds made of? So the goal of cloud spotting on Mars is to find and map mesospheric clouds on Earth in order to create a database that will be used to answer these questions. So what they're wanting right now is just a bunch of examples of clouds that they can then reference in their research. And the data comes from the Mars Climate Sounder on the Mars Reconnaissance Orbiter, which is that image on the left. That's an artist rendering of it. It's currently orbiting Mars, and it's sending data back to Earth. And this is what will be used to create a citizen scientist curated map of Mars's clouds. So to participate, as the Mars Reconnaissance Orbiter moves around the planet, clouds create an arch-like shape in the data. The peak of the arch is the location of a cloud. It is these arches that you'll be looking for. An arch is going to have two legs and a peak. And you'll be marking these arches with the Arch Peak Marker tool. And again, your trusty field guide has examples of what you're looking for. So you can always refer back to it to make sure that what you're seeing is what they're looking for. So from Mars, let's move back to Earth. This is called the Aurora Zoo, and the Aurora Structure and Kinetics Camera System is operated by the University of Southampton. It uses telescopes to look at a very small part of the sky in detail, allowing us to see the smallest shapes in the northern lights, which is also referred to as the aurora. The ASK has been operating on Svalbard since 2007, and it takes video anytime it is dark. This means that there are thousands of hours of video that needs to be looked through. An Aurora Zoo seeks to understand how different small-scale shapes and movements in the aurora are formed, and to learn what conditions are needed for those different shapes and movements to happen. So what citizen scientists will be doing for this project is identifying the shapes in the aurora by viewing clips of it. Energy from the northern lights does need to be included in atmospheric and climate models, but it's difficult to predict how much energy in the form of heat there will be, where it will be, and how much of it is focused or spread out over an area. And because this is studying such a small scale area of shapes and movements in the aurora, we get a window into the physics of energy process present. Understanding how they form is going to be a step toward understanding the energy flow into the atmosphere. Studying the aurora can also help us figure out how to predict and prepare for geomagnetic storms, which can cause satellite malfunctions and even power grid failures. So to participate, Aurora Zoo asked participants to identify the shapes and movements in short clips of the northern lights. So you can see on the screen here, that's still from a video of the Northern Lights. And you'll be identifying shapes as one or more arc, coronal rays, an edge, aurora everywhere, black aurora, irregular blobs, patchy, or no aurora. And the field guide will give you a written definition of each of these classifications, as well as multiple visuals of what they look like. Gravity spy. So in 2015, the Laser Interferometer Gravitational Wave Observatory, or LIGO, detected gravitational waves for the very first time. LIGO is very sensitive, so it is susceptible to instrumental and environmental sources of noise. And these are referred to as glitches. And glitches are difficult for computers to model and can even mimic a real astrophysical signal. Overall, they make LIGO less sensitive to those gravitational waves that it's trying to detect. So Gravity Spy's goal is to figure out the origin of different glitches so that LIGO scientists can work on eliminating them. And the image on the left is one part of that observatory. It's quite large. So to participate, you will be asked to look at a spectrogram that is showing a glitch. That glitch is going to be at the very center of the spectrogram, and you're identifying that glitch as either being a blip, a whistle, or neither. And neither is important because new glitches are appearing in the data all the time, so this can help them figure out that they have a new type of glitch. So moving on from Earth, we're going to head back out into the solar system, specifically toward asteroids. So this citizen science project has participants looking at images to find asteroids. An all-sky camera image, that's what this is on the right, is from December 11th, 2024 at 1:09 p.m. And it is from a telescope in Arizona that is used in this survey. So this is a picture of the sky. And since 1998, the Catalina Sky Survey has discovered thousands of asteroids. Even with state-of-the-art cameras, detection software, and a team of professional observers, they are still unable to sort through all the data. And why are we studying these near-Earth asteroids? The probability that a large asteroid would hit Earth is very low, but the Catalina Sky Survey still needs to identify near-Earth asteroids and track them. The variation in composition, shape, and density of asteroids have clues to the structure, composition, and formational history of our solar system. In the future, the metals, mineral resources, and even water contained on near-Earth asteroids could support space exploration as humans go further out into our solar system. So you will be looking for possible new asteroids captured in the Catalina Sky Survey's archival images. Their asteroid detection software has already detected possible asteroids, but unfortunately, most are false positives. You will be looking for real asteroids in the images. Essentially, you're checking the work of a computer. So this project is also on the Zooniverse platform, just like the other ones were. And when you click Get Started, you'll be taken to your first image. There'll be a tutorial, and this tutorial is going to pop up on any project that you do, and it'll walk you through what you need to do. But essentially, you have a picture on your screen, and suspected asteroids are circled in green. When you click play, that circle is going to move. If you see an object moving inside that green circle, congratulations, you found an asteroid. And the field guide will show you pictures of what an asteroid looks like in photos and what some common false detections look like. So you can refer to that field guide to compare what you're seeing in the images with the example images. Moving beyond the asteroids, let's take a look at Backyard World's Planet 9. So right now, we know about 8 planets that are orbiting the sun. We're currently on one of them. but there may be more. In fact, patterns in the orbits of comet-like objects in the Kuiper belt suggest that there is a ninth planet past Neptune. They're not referring to Pluto, who is no longer part of the solar system as a planet. And so the image here on the left with the diagram shows the orbits of some of the Kuiper belt objects that suggest the presence of a planet 9, as well as a possible orbit for it. Models of this planet even imply that we may have already captured a picture of it with NASA's WISE telescope. We just don't know it. And the images taken by the WISE telescope, or the WISE Field Infrared Survey Explorer, are infrared. And Planet 9 should glow in that infrared. So to participate, you'll look at false color images that were created combining images from a span of 5 years. This collection of images is called a flip book. Looking through pictures from a time span of 5 years helps you to notice objects of interest. Now, this technique is similar to, but more high-tech than, the way that Clyde Tombaugh discovered dwarf planet Pluto in 1930. So it's a similar technique, you're just using more advanced technology. And you'll click Classify to start. And as with other projects, that tutorial is going to pop up to walk you through what you need to do. And you'll be marking a slow-moving objects as dipole and fast-moving objects as movers. So you're looking for things that are moving slow and things that are moving fast. And you can see examples of those in the screenshot on the far right. So going beyond even our own solar system, let's take a look at Exoplanet Watch. Now, these next 3 opportunities, including Exoplanet Watch, are not available through Zooniverse, and they do require a greater time investment. So if you're really into doing this sort of thing and you have the time to devote to it, this will be perfect. So exoplanets are planets beyond our solar system. So there are 3 examples we can talk about. There's TO1-1452b, and it's an exoplanet orbiting a red dwarf star 100 light years away. It is 70% larger than Earth, and its density indicates a deep ocean surface. WASP 103b is the first non-spherical exoplanet that's been discovered. It is twice the size of Jupiter and is in the constellation Hercules. And TYC 3998-7601b is a gas giant 300 light years away, orbiting a 17-million-year-old star, which is actually really young for a star. And NASA wants to find more exoplanets, so they've turned to citizen scientists to help them with their search. When an exoplanet orbits between its star and Earth, something called a microeclipse occurs. This is because a planet blocks a small percentage of that star's light. And when this brightness is graphed over time, there will be a dip in the light curve. This graphing is done by NASA's open source cloud-based software called EXOTIC, which stands for Exoplanet Transit Interpretation Code. And there's going to be 2 ways that you can participate in Exoplanet Watch: with your own telescope or with images shared by NASA. So for our program today, we are going to only look at the option to use images shared by NASA. If you have a telescope and want to participate that way, there are instructions on the project's webpage. I go back, I went forward too soon. Sorry about that. NASA has partnered with the Micro Observatory to get robotic telescope observations of transitioning exoplanets. So users can request data once every 48 hours, and all you need is an active email. This waiting period helps to avoid overloading the system. When you receive data via email, it enters a probationary period when it is not shared with anyone else. Later, it will be put back into circulations for others to work on, but the copy that you have downloaded will stay on your device. And there are two ways to use Exotic to analyze your observation. You can use the Google Colab Cloud version, which does require a free Google account. You can download and run Exotic on your own computer, and instructions for both of these options can be found on the project's website. As I mentioned when we first started this section of the presentation, these take a little bit more time than the others. So if it's something you're really interested in, I encourage you to really read through everything that is available on those websites. Let's head closer to home. This can be your own backyard, and talk about Globe at Night. This project has participants measuring the darkness of the sky above them once a month. So while you need to do it at a specific time and make a few detailed observations, it is something you would do just 12 times a year. Now, 7 out of 10 people in the United States have never seen the Milky Way from their own yard. This is due to light pollution, and light pollution is a pretty serious issue. Not only does light pollution block our view of the stars, unnecessary outdoor lighting wastes energy and money between $2 billion and $10 billion a year. Exposure to light pollution causes sleep disorders in humans and disrupts the sleeping, breeding, and migration habits of animals. So NASA is working on creating a worldwide map of light pollutions, and your observation can help them in the creation of this map. So you can see on the screen here, it's kind of the whole realm of no stars to excellent dark sky sight. And as a suburban city, Plano is probably around 2 or 3 or 4. So to participate in this one, you're going to go outside at least an hour after sunset while the moon is not yet visible, or when there's a new moon. The moon can be pretty bright, so doing this on the night of the new moon might be your best option. So give yourself at least 10 minutes for your eyes to adjust to darkness. Now, if you need light to take notes for your observations, consider using a red light flashlight. In low light conditions, your pupils are going to dilate. So if you're outside in the dark, your pupils are dilated. And as soon as you turn a light on in that darkness, your pupils are going to constrict, and this ruins your night vision. So using a red light will minimize pupil dilation, which will preserve your night vision. And you're going to choose a constellation that should be visible in the night sky and look for it in your night sky. And Globe is going to tell you this is the one we're looking for. And you're going to count how many stars you can see compared to how many stars you should be able to see. Now for this one, use only your eyes. Don't use a binocular or a telescope, just your eyes. And you're going to record the date and time of your observation, your location and elevation. Now, once you go to upload your data on the website, the form should auto-populate with the latitude, longitude, and the elevation of your location. So don't worry too much about accurately determining this on your own. And you'll make some comments about the location. Is it rural, suburban, urban? How many light sources are there? And the trees and structures that are present. If you have a sky quality meter, you can record its reading, but it isn't required to participate in this project. And then you're going to choose the magnitude of your chosen constellation. You'll add the sky condition. So is it clear, quarter of it cloudy, half of it cloudy, more than half of the sky cloudy? And sky condition comments. Is it hazy? What kind of clouds do you see? Is there a distant light dome visible? In which direction? And then you'll just click Submit Data. Now this next one is taking us back to the Northern Lights. It's called Aurora Soris. And while we typically don't always get the aurora down here, it's still an option to participate. So Aurora Soris seeks to generate informal educational materials, activities, and resources that will help translate the complex science of the aurora so it is more accessible to the general public. This project generates a real-time global map of the aurora via reports. So this also means you can use it as a tool to see if the aurora is visible near you, and it does sometimes make an appearance down here. Now, auroras typically refer to the northern lights, the aurora borealis, or the southern lights, aurora australis. They are a natural interaction between the sun and Earth's atmosphere. And when plasma from the sun reaches Earth's magnetic sphere, some of the electricity charged particles get trapped in Earth's atmosphere and bounce between the north and south poles. When these particles release their extra energy, we see glowing lights. So to participate, this project has participants submit reports of the auroras that they see. Now, Texas rarely experienced the northern lights, but as we saw in fall of 2024, it can happen. You can also submit observations if you are traveling. And they're saying right now we're kind of in a heightened period of solar events. So there's a possibility that we may see it down our way again within the next year. So you are going to record your location, the observation start, date and time, and your observation in date and time, and what colors you saw in the aurora. Were there discrete arcs? Was the glow diffuse, patches, pulsating, or other? And how active is the aurora? Is it quiet, not moving much, active motion, very active, racing across the sky? And then any other comments that you think are necessary to include. And you have the option to upload a picture as well. Now, please note, you can only submit 100 observations in a day. So on your 101st observation of the aurora, you're not going to be able to submit that one. And even negative reports are helpful. If an aurora is forecasted in your area and you look for it and you don't see it, still submit your observations. This can help improve the viewline prediction models, which if we go back, this map here is saying if this was early December, this is when they were saying the aurora would be visible and where. And so if you were close to the edge and they were like, hey, this part of the country might see it and you don't, that is helpful for them to know because that means, hey, they were off a little bit. So many of the projects we've looked at today require very little work on your part, and it can be easy to think what you do is not making an impact, but it does. So let's look at some examples of citizen science success. Since we just talked about Aurorasaurus, we'll jump in with that one. In 2016, citizen scientists discovered a new aurora-like phenomenon that was named STEVE. STEVE is short for the Strong Thermal Emission Velocity Enhancement. And STEVE is a streak of magenta light with green bars. And there's a picture of STEVE on the screen there. And recently, researchers used citizen science data to find that the magenta peaks at 124 miles high up in our atmosphere, while the green peaks at 68 miles up. Those green bars are 8.7 miles apart, and STEVE moves at about 560 miles per hour. Before I heard this, I had kind of assumed that there were just two types of auroras. Now there's STEVE. Now, this is a project that's currently out of data called Exoplanet Explorers, but they've had some success with this one. In 2017, there was a system of at least 5 exoplanets discovered by citizen scientists, and that system has been named K2-138. This was the first multi-planet system discovered entirely through citizen science. So this project is currently out of data, but it is on Zooniverse, and if it seems like something you're interested in, keep checking back to see if more data has been added to it. Now, Backyard World's Planet 9, they discovered a moving object. It is so fast, about 1 million miles an hour, that it will eventually escape the Milky Way's galaxy's gravity and shoot out into intergalactic space. And it has been named CY's J124. So this is something that citizen scientists discovered through the Backyard World's Planet 9 project. All right, well, what is next? So there are many space-themed citizen science projects on Zooniverse. You can explore them and other projects on Zooniverse's website. So in addition to space, there's natural history, there's language, there's history, there's a lot of projects on Zooniverse. And if citizen science really interests you, on April 7th, also at 6 o'clock, we will be discussing the iNaturalist Citizen Scientist tool. So we're going to have one of these each month. If you have registered for this program, you are already registered for that one. All right, well, if you have any questions you would like to ask, you can go ahead and drop them in the chat and see what we can do to answer them. And if you think of something later, you can always send us a question through Ask a Librarian on our website. If you make sure and mention that you were on these, or you attended the Citizen Science Project, the people monitoring that will make sure it finds me.
I'm not seeing any questions in the Q&A or the chat. If you do have questions, both of those are open for you to post in those two areas.
All right. Well, thank you everyone for joining us tonight. We appreciate you being here. Be sure to stay up to date with Plano Public Library by following our Facebook page and our Instagram. You can find recordings of past programs on our YouTube channel. I also want to mention if you're just interested in natural history in general, the Davis Library is currently incubating some chick eggs that should start to hatch on March 17th. We'd love for you to swing by and take a look. Please complete our program survey, which should pop up following the program. We value your feedback. Thanks again for joining us today, and we will see you next time.